Hello friends, welcome to my channel Technical Arco and myself Arnab Kundu. Today I will discuss on thread. Thread is actually a lightweight process, okay? I will show you the comparison between thread and process, and also I will discuss process and thread separately. So go to the computer screen. So today I will discuss the topic thread, okay? So at first we should know what is thread. A thread is a path of execution within a process, right? A process can contain multiple threads, okay? Now we talk about multi-threading. A thread is also known as lightweight process. The idea is to achieve parallelism by dividing a process into multiple threads. For example, in a browser, multiple tabs can be different threads, okay? For an example, another MS Word uses multiple threads, like one thread to format the text, another thread to process inputs, etc. Okay. The primary difference is that threads within the same process run in a shared memory space, while processes run in separate memory spaces. Okay. Threads are not independent one another like processes are. Okay, and as a result threads share with other threads their code section, data section and OS resources like open files and signals. Okay, but like processes, a thread has its own program counter, means the PC, okay, also register set and stack space, right? Now we talk about the advantages of thread over process. The first number one is responsiveness. If the process is divided into multiple threads, if one thread completes its execution, then its output can be immediately returned. Okay. Number two, faster context switch. Context switch time between threads is lower compared to process context switch. Okay. Process context switching requires more overhead from the CPU. Okay. Next point, effective utilization of multiprocessor system. If we have multiple threads in a single process, then we can schedule multiple threads on multiple processor, right? This will make process execution faster. Next point, resource sharing. Resources like code, data and files can be shared among all threads within a process. Should be noted, stack and registers cannot be shared among the threads. Okay, each thread has its own stack and registers. Okay, next point, communication. Communication between multiple threads is easier as the threads shares common address space, while in process we have to follow some specific communication technique for communication between two processes. Okay, and the last point, enhanced throughput of the system. If a process is divided into multiple threads and each thread function is considered as one job, then the number of jobs completed per unit of time is increased, thus increasing the throughput of the system, right? Now we talk about the types of threads. There are two types of threads are there. One is your user level thread, another is your kernel level thread. For case of user level threads, all code and data structure for the library exist in user space. Invoking a function in the API results in a local function call in user space and not a system call. Okay, but in case of kernel level threads, all code and data structures for the library exists in kernel space. Invoking a function in the API typically results in a system call to the kernel. So there is a user space where the user level threads are there, and this is your kernel space where kernel level threads are there. Okay, now we talk about more about user level thread and kernel level thread. User threads are implemented by users, but in case of kernel level thread, implemented by OS. In case of user level thread, OS does not recognize user level threads, but kernel threads are recognized by OS. Implementation of user threads is easy. Implementation of kernel threads is complicated. Okay, Context switch time is less in case of user level threat, but context switch time is more in case of kernel level threat. Context switch requires no hardware support for user level threat, but hardware support is needed for kernel level threat. Okay. If one user level threat performs blocking operation, then entire process will be blocked. If one kernel thread performs blocking operation, then another thread can continue execution. Okay. User level threads are designed as dependent threads, but kernel level threads are designed as independent threads. Okay. Examples for user level threads are Java thread, POSIX threads, but examples of kernel level threads like Windows, Solaris, etc. Okay. A thread is similar to the sequential program, right? A single thread also has a beginning, a sequence, and an end. At any given time during the runtime of the thread, there is a single point of execution. However, a thread itself is not a program. A thread cannot run on its own, rather it runs within a program. The following picture shows that a thread is a single sequence flow of control within the program, right? The real excitement surrounding threads is not about a single sequential thread, rather it is about the use of multiple threads running at the same time and performing different tasks in a single program. So according to this picture, multiple threads means there are two threads running at the same time and performing different tasks in a single program, right? Now we talk about process. A process is the execution of a program that allows you to perform the appropriate actions specified in a program. It can be defined as an execution unit where a program runs. The OS helps you to create, schedule and terminates the processes which is used by the CPU. The other processes created by the main process are called child process. Okay. A process operations can be easily controlled with the help of PCB, means process control block. We can consider it as the brain of the process, which contains all the crucial information related to the processing like process ID, priority, state, and contains CPU register, etc. So the picture provides the lots of information related to a process using this PCB diagram. Okay. A process control block is a data structure used by computer systems to store all information. It is also known as a process descriptor. Okay. When a process is created or initialized or installed, the OS creates a corresponding process control block, right? Now we talk about some properties of thread and process. Here are important properties of threads are single system call can create more than one thread. Okay. Threads share data and information. Threads shares instruction, global and heap regions. Okay. However, it has its register and stack. Thread management consumes very few or no system calls because of communication between threads that can be achieved using shared memory. Okay. And here are important properties of the process, and their creation of each process requires separate system calls for each process. Okay. It is an isolated execution entity and does not share data and information. Processes use the IPC, means inter-process communication mechanism, for communication that significantly increases the number of system calls. Process management takes more system calls. A process has its stack heap memory with memory and data map, right? Now I just provide the difference between the process and the thread and give some parameters. So at first the parameter is the definition. So in case of process means a program is in execution. Thread means a segment of a process. Okay. Parameter lightweight. The process is not lightweight. Threads are lightweight. The parameter is termination time. The process takes more time to terminate. The thread takes less time to terminate. Next parameter, creation time. In case of process, it takes more time for creation. In case of thread, it takes less time for creation. Next parameter, communication. In case of process, communication between processes needs more time compared to thread. In case of thread, communication between threads requires less time compared to processes. The next parameter is context switching time. In case of process, it takes more time for context switching. In case of thread, it takes less time for context switching. Next parameter, resource. Process consumes more resources. In case of thread, it consumes fewer resources. Next parameter, treatment by OS. Different processes are treated separately by OS. All the level peer threads are treated as a single task by operating system. Next parameter, memory. The process is mostly isolated. Threads share memory. Okay. And the last parameter, sharing. Process does not share data. Threads share data with each other. Right. Thread is an execution until that is part of a process. A process can have multiple threads all executing at the same time. It is a unit of execution in concurrent programming, right? A thread is lightweight and can be managed independently by a scheduler. It helps us to improve the application performance using parallelism. Okay, multiple threads share information like data, code, files, etc. Okay, I hope that you have understood today's topic. For more videos, keep watching my channel Technical Arquin. Thank you and bye bye.